Welcome back. What I'm talking about is something called closures. What's the hardest JavaScript concept to understand? Then many people would say it is closures. It's actually not that hard, especially when you understand everything that you learned before in this course, such as execution context, the call stack, and then the scope chain, because closures kind of bring all the concepts together. Let's see what closures are all about. I'm going to start by creating a new function here called the secure booking, and it is the function that will create the closure. Now the first thing that I need to tell you about closures is that closures is not a feature that we explicitly use, and so we don't create closures manually like we create a new array or a new function. So closure simply happens automatically in certain situations. We just need to recognize those situations, so that we are going to do here in this example. So we'll create one of those situations so that we can have a take a look at a closure. Anyway, let's continue writing this example here. So we'll just start by here say, so we'll just start by creating here constant secure booking, and then here we'll just say function, and here I will just say let passenger count equals to 0. I'm calling it a secure booking because this passenger count variable cannot be manipulated and accessed from the outside. So now it will return the function, right? So here we'll just say return function of, and here we'll just have our passenger count increased, and here we'll have console.log passenger count passengers. So let's call a secure booking function and then store it the result in a variable called bookers. And so this is very pretty similar to functions returning to the functions. So let me just say here constant booker equals to secure bookings. So let's analyze the code in detail. What happens when it is executed using all the concepts that we already know about. So this is exactly the code that we just wrote. Now before we start running the secure booking function down here, our code is running in the global execution context, and so in there we are currently only have this secure booking function. So we can also say that global scope now contains secure booking, and then when secure booking is actually executed, a new execution context is put on top of execution stack. And now remember, each execution context has a variable which contains its local variable. In this case, it only contains the passenger count set to 0. The variable environment is also the scope of this function. So the scope chain of the execution context looks like this. So passenger count is in the local scope, but of course this scope also can get access to all variables of parent scopes. And just in case a global scope, anyway, in the next line of secure booking function a new function is written. It will be stored in the bookers variable. So the global context now also contains the booker variable. All right, so now what else happens when the secure booking function returns? That's right, its execution context pops off the stack and disappears. So the secure booking function has done its job and has now finished execution. Now it's very important to note that it's only the execution context itself that is gone from the stack. The variable environment containing passengers counts is stored in memory, and in particular this variable environment has been transferred to the heap in the case, but more on the later. Again, the execution context is gone at this point, but the variable passenger count is set to 0, still lives on the engine's memory, and it is very important to keep in mind moving forward. All right, but most of this is actually nothing new at this point. All we did was analyze the call stack and the scope chain, as we call the secure booking function. So this is going to be very important to understand and see closure. So yet we didn't see any closure yet. All we did was using the knowledge that we already have to understand how this booker function was created. And now let's go back to our code to actually use the booker function and finally see the closure in action. So here we are going to run booker functions multiple times, here the 3 times. And now, as you can see, as we reload here, we got the output as 1, 2, 3 passengers. Okay. And so what this means is that Booker function was in fact able to increment the passenger count to 1 and then to 2 and then to 3. But now if we think about this, then how is this even possible? How can Booker function update this passenger count variable that's defined in a secure booking function that actually has been finished executing? So just I said the function has already been finished its execution, it is gone, so the execution context is no longer on the stack. So we just saw in the slide, but still the inner function here, which is the booker function, is still able to access the passenger count variable that's inside of this booker function that should no longer exist. Maybe you can guess what makes it possible is a closure. So this Booker function here is simply a function that exists out in the global environment or in the global scope, and the environment in which the function was created, the environment is no longer active. It is in fact gone, but still the Booker function somehow continues to have the access to the variables that were present at the time that the function was created, and in particular passenger count variable here. So that's exactly the closure does. So we can say that a closure makes a function remember all the variables that existed or at the function's birthplace essentially. So we can imagine the secure booking as being the birthplace of this function. So of the bookers function essentially. So this function remembers everything at its birthplace by the time it was created, and this cannot simply be explained with the scope chain alone. So we need to also understand the closure. Now, this is how we left the stack and the scope chain after the last slide. Let's now start by remembering that execution context of secure booking was popped off of the call stack. After that, function finished running together with the variable environment. Now also remember how we set the environment which contains the passenger count variable is stored in the memory. But why is that? Didn't we learn earlier in this lecture about the garbage collection? The value variables stored in the stack are destroyed as soon as the execution context pops off the stack. Well, yes, we did, because that's usually because the case. There is, however, one exemption that we talked about, and the exemption is of existing of a closure. So remember how we said that if an object is reachable by a closure, it cannot be garbage collected. Therefore, it stays in the heap indefinitely, and that actually applies to the object in the heap and to variable environments of variables that are stored in the stack as long as they are reachable by a closure. So in summary, the passenger count variable still exists because in fact reachable by a closure. That's only reason. Otherwise, it will still be gone. But in this case, the engine moved the variable environment to the heap where it can stay forever. Again, because it's reachable by a closure and can therefore not be garbage collected. That is why the passenger count variable still lives on. So the way memory and the garbage collection works plays an essential part here. Well, again, I told you in this lecture, everything comes together. And so to make sure that you understand all this stuff that we learned earlier, in this case, that we learned about the memory management and garbage collection. Anyway, it's time to finally run the Booker function and see what exactly going on here. And by the way, note that Booker is really the function here. So located in the global scope. Okay. So the first thing that's going to happen when we run this function is a new execution context is put on the top of the call stack. Okay. And the variable environment of this context is empty simply because there are no variables declared in this function. So what about the scope chain? Well, since the Booker is in the global context, it's simply a child scope of the global scope, just like maybe now looking at this scope chain, you are starting to see a problem here. However, the Booker function accesses the passenger count variable. It is now here to be found in the scope chain of this function. So this is where we are going to start to unveil the magic of this closure. I mean, we already know the closure exists, but we saw it in our code. We don't really know what it is and why it exists in the first place. So it basically any function has access to variable environment of execution context in which functions was created. In case of Booker, this function was created, so it is born in the execution context of secure booking, which was popped off the stack previously, right? So therefore the Booker function will get access to the variable environment which contains the passenger count variable, and that's the magic trick here. So how the Booker function will be able to read and to manipulate passengers count variable, so that this connection is where the we call the closure. So let's say that again, make this really clear. So a function always has to access the variable environment of the execution context in which it was created even after the execution context is gone. And that the last part is really important. The closure is then basically this variable attached to the function exactly as at this time and place that function was created, and probably still sounds confusing, but don't worry. For now, we are just trying to understand the mechanism behind the closure. So how it works behind the scenes, what matters the most here is that Booker function has access to the passenger count variable because it basically defines in the scope in which the Booker function was created. So in a sense, so the scope chain is preserved through the enclosure when a scope has already been destroyed but its execution context is gone. This means that through the execution context has already been destroyed, the variable environment somehow keeps living it somewhere in the engine. Now we can say that the Booker function closed over its the parent scope over its parent's variable environment, and that includes all the function arguments, even though in this example we don't have any. This attached or closed variable environment stays with the function forever. It carries around and be able to use it forever to make it more digestible. And we can also say that thanks to this closure, a function does not lose connection to variables that exist at their function birthplace. That's bit more intuitive, right? But anyway, let's see what happens now with the execution of Booker function. So the function attempts to increase the passenger count variable. However, the variable is not the current scope. So the JavaScript will immediately look into the closure and see if it can find the variable there. So after running this function, the passenger count becomes 1 and then the message is logged, and then the execution context is popped off the stack, and then the execution moves to the next line. We get a new execution context at this closure is still attached to the function and the value is 1, and now this function executes increase and the passenger counts to 2 and logged a message again. And that's what closures are, how they work behind the scenes. And I know this is all quite complex, so let me give you a couple of different definitions of closures now. The most formal definition of closure is the one we already saw, which is a closure that is closed over variable environment of execution context in which a function was created, even after the execution context is gone. In other words, even after the function to which the execution context belongs has returned. And next, a bit easier to understand, a closure gives the function access to all the variables of its parent's function. So the function in which it is defined whenever the parent has returned. So the function keeps a reference to its outer scope even after the outer scope is gone, which is basically preserved the scope chain throughout the time. All right. Another definition, let's just say, analogy is that a closure makes sure that a function does not have loose connection to the variables, so that exists at the function birthplace. It remembers the variables even after the birthplace is gone, like a person who doesn't lose connection at their hometown. In this analogy, the person is the function and the hometown is the function's parent scope, and the function that does not lose the connection to the variable stored in the parent scope. And I hope that makes sense. Finally, some people like to think of this attached variable environment as a backpack. So in this analogy, a function has a backup which is carried around whenever it goes, and this backpack contains all the variables that were present in the environment in which function was created, and then a variable can be found in function scope. JavaScript will look into a backpack and then take the missing variable from there. A kind of similar to other definitions, but maybe a little bit more visual. So so there are some different ways of defining closure. By they all means the same thing, so they all represent the same idea. Finally, we need to understand what we don't have to create closures manually. Instead, there is something that JavaScript does completely automatically. We don't have to do anything. Also, there is no way for us to explicitly access closed over variables. That's because closures are not like a tangible things. They are like an object so that we can access. So we just cannot reach into a closure and take variables from it. That's impossible because a closure is just an internal property of a function. We can just observe the closure happens because functionality magically having these access to variables that should no longer exist, but we cannot directly access these variables. However, we can do is actually just look at this internal property. So at this backpack, so to say in the console, let's quickly do that before we finish this lecture. So here we just say console.log. So here instead of console.log, here we just say dir, and then here we'll just say booker, and then we'll just save it. As you can see here, we got our function f here. So when you open it, see here, it has prototypes. As we get the arguments, the name of the property, we already look at it before. And down here, we have this scope internal properties, as you can see here. So it is basically the variable environments of the booker function. Now in here, we can just actually see the closure coming from the secure booking, and it is where we see the passengers count, which currently stands at 3, and it is closure here. Basically, it is the variable environment of the secure booking. So that's the one it is being preserved by the closure. By the way, whenever you see these double brackets here, okay, that means it is an internal property which we cannot access from our code. Now in the next lecture, we are going to look at the 3 more examples of closure and also analyze how they works, because it's really important that you understand this concept of closure. It's features that that's used all the time in JavaScript, and many times even without us realizing that closures are happening. And you always need to know how exactly everything in your code works, and that of course includes closures. So that's it for this session. Thank you.